Hi guys, this is Chapter 10, Lesson 4 on surface area of triangular prisms. What you're going to need today is a sharpened pencil, your math book open to pages 773 through 776, and a sheet of notebook paper. A couple things that I don't want you to forget is you need to make sure you copy it all down, so everything that we're doing we're going to copy down, and I really need you guys to stay focused. There's a lot of information being presented in this lesson, so if you're partially distracted by the TV or your phone or something else that's around you, then you need to go ahead and turn it off or move to a quieter location so you can focus and get this all done and understand it for when you're back in class. So let's talk about the things that we're going to be covering in this next lesson. So we're going to be talking about the relationship between the area of the faces of our triangular prism and the surface area of the triangular prism. And the second thing is we're going to be talking about how to use nets to find the surface area. So look at the real world link. So what we're going to do is we're going to use the picture that we have here in the center of this page, and we're going to fill in the table that is drawn below. So it says here that Raj and his dad are building a ramp to move his dirt bike onto a trailer. So we're going to talk about number one, where it says the face, like what shape is the face in. So we're talking about the front part. So this is the part that we're talking about that I have highlighted here in red. Well, it wants us to draw that face. So go ahead and take a moment to draw that face and label what shape it is. Well, it's in the shape of a triangle. Now we're going to talk about the back part. Well, the back is in the shape of a triangle as well, and it happens to be the same exact size and shape as that front one that we just got done drawing. Now we're going to talk about the top part of this ramp. The top part of the ramp is in the shape of a rectangle, so we're going to go ahead and draw that rectangle and label it. So if the top is a rectangle, then the bottom, that too has to be in the shape of a rectangle as well. And then we've got one more piece, which is that side little itty bitty piece. So it's like over in the corner there that you can see that I've got outlined in red. That too is in the shape of a rectangle as well. So what I want you to notice here, and this is going to be true for every triangular prism, is that they all have two triangles that will be the same size and shape. And you also have three rectangles. Now, notice though, not every rectangle is going to have the same size and shape. So just be careful of that when you're trying to figure out the total surface area of a triangular prism. So looking over at the next page. So here you can see that they gave you a picture of a three-dimensional figure, which is really like what I kind of like to use when I'm doing my problems. And they also gave you a picture of what that three-dimensional triangular prism figure looks like if you were to unfold it or cut it apart, and this is what its net would look like. So the first couple of examples that we're going to be dealing with is we're going to be talking about triangular prisms that have bases, so their bases are triangles, but remember they're not always going to sit on that triangle piece. So we're going to be talking about triangular prisms that have bases that are equilateral triangles. What that means is that the triangle will have three sides naturally, because all triangles do, but all three sides will be identical in size. So let me show you an example here. So if we're going to look at our first picture here that we have up here, notice this guy right here. That line is going to be the same as this line, and it's going to be the same length as that line. You can see my triangle is a little off, but you kind of get the idea. So an example of a triangle that it would not be considered equilateral would be maybe something that looks like this. Two really, really long sides and a little short base. This one is an example of a triangle that is not equilateral. So we're going to be talking about equilateral triangles. So when your triangular prism has an equilateral triangle in it, you're going to realize that they're going to have the same numbers, and then you're going to realize like what happens to those rectangular faces. All right, so before we move on, let's go ahead and get the rest of this information written down here. So just another reminder, triangular prisms will have two triangles and three rectangles. And you can see here I drew another example of what a equilateral triangle is not. So let's go ahead and look at example 1. Here in this one, we're going to show you how to find the surface area of a triangular prism. Now, they gave you two pictures here. They gave you the three-dimensional picture with all the numbers coming out of it, and they also gave you the same exact picture. However, they gave you the net of the same, I should say they gave you the net of the same exact triangular prism. So looking at this now, the book has it one way. So if you look over in this area right over here, the book has a bunch of numbers here, but I want to make sure that you guys understand where all those numbers came from. So we're going to break it down. So this means that the way I'm going to break it down is the way that you must do your work for me, because this is not going to fly for me. And you guys know me at this point. So you do need to show me formulas and how everything's going to fit together. So I like to start with triangles. So when I'm finding the surface area of a triangular prism, I like to find the area of my triangles first. So what I'm going to go ahead and do is over in my work zone, I'm going to go ahead and label triangle down, and then I'm going to go ahead and list the formula for area of a triangle. So I'd like for you guys to do the same thing. So now I'm going to go ahead and look at my picture, and it doesn't matter which picture you're looking at, whether you're looking at the three-dimensional figure or the net. I'm going to go ahead and just show you the net though right now. So I'm going to be looking over at this area right here. So I'm going to go ahead and outline the triangle that I'm going to look at. So it's this guy right here, this one, and this one. So remember, the two numbers that you need for a triangle is you need to find the height of the triangle, and they gave us that right here that I've got circled, but you also need to find the base of the triangle. Now look at the base that I have outlined. There's no number there for the base. So you guys, this is the base part right here. Well, look straight down, okay, right here that I'm pointing to. This line right here is also the base. So look what number's with that base. It is 1 centimeter. So I'm going to use those two numbers over in my formula. So over here I'm going to go ahead and write 1/2 times my base was 1 and my height was 9/10. Alright, so now we know anything times 1 is that number, so we really don't have to worry about the 1 a whole lot. But let's go ahead and go in order. 1/2 times 1 is going to give us 1/2. Well, now I need to do 1/2 times 0.9. So I'm going to go ahead, and you can do this a couple ways. You could take your 0.9 and divide it by 2, or you can take your 1/2 and change it into a decimal, which is what I'm going to do, and I get 0.5, and I'm going to multiply it by 0.9. 9 times 5 is 45. Now look at your decimal points. You have 1 right here that I made really big, so there's one spot that comes after that decimal, and here's another decimal that I made really big, and another spot comes after that one, for a total of 2 spots, 1, 2. That means my answer, I have to go in 2 spots for my decimal point. So down over here on my answer line, I'm going to say that the area of my triangle is 45 hundredths centimeters. So now, we're going to remember that. So how many triangles do we have? We have 2 of them. So one of them is 45 hundredths. So let's go ahead and get moving on to the rectangle part now. So sorry about that. That was little Jackson just letting me know that he had a nosebleed. All right, so that's taken care of. So let's go back to our example. So we left off, I believe, with rectangles. So we're going to go ahead and write out rectangle. And remember, the formula for the area of a rectangle is area equals base times height. So I'm going to go back to my picture here. So let me go ahead and take out all these other marks that I made in here. So I want to look at just my rectangle part. So of course, we have 3 rectangles that make up this triangular prism, and they're all going to be the same exact size. So look at this rectangle right here that I'm outlining. It's going to have the exact same dimensions as this middle rectangle, and it's going to have the same exact dimensions as this far right rectangle. So let's look at the base of this rectangle. So we have 1, and that's listed right here, and our height is 2 centimeters, because I've got to look all the way to the right to get that number. So if this line over here is 2 centimeters, that means this guy over here is going to be 2 centimeters as well. So let's go ahead and plug in that information into our formula. So we said that our base was 1 centimeter, our height was 2. 1 times 2 gives us 2. So that was pretty easy. All right, so now we actually have all the numbers that we need. However, you have to remember what we said earlier. There are a total of 2 triangles, which means I need to take my 45 hundredths and add 2 of them together. Let me fix that. So when I add 45 hundredths plus 45 hundredths, I end up getting 90 hundredths, or 0.9. Now what I'm going to do is, you see this 0 that comes after the 9, it's unnecessary. We're not talking about money, so we don't need that second decimal spot. So I'm just going to drop that guy off. So the area of my two triangles put together is 9/10 of a centimeter. So now I'm going to take that part, and so remember, this is for one triangle, this is for the other triangle. So now I'm going to go ahead and add in my rectangle. Now look where I'm putting my 2. I know it looks lopsided. However, the reason why I'm doing that is because I have to line up my decimals. And I know a lot of you are going to want to put that 2 underneath that 9. Well, that's wrong. You're not going to get the same thing. Or the correct answer. So if it bothers you so much, we can go ahead and fill in this spot with a 0. So we're going to add these numbers together. We're going to get 2 and 9/10. Now this was for just one rectangle. Remember, how many rectangles do we have total? 3 of them. So that means we have to go ahead and add in another rectangle. So once again, I'm going to go ahead and line up my decimal spots. And now I'm going to get 4.9. I'm going to go ahead and change my color because I don't know if you guys can see the purple on the black part. And then we need to go ahead and add in one more rectangle. And this is our other rectangle. And we get a total of 6.9 centimeters squared. This is our surface area. So remember, we're going to use A period for surface area. So that's our surface area of this triangular prism. Now it's your turn to try. So on this example here, I want you to find the surface area of the triangular prism that is shown. So if it helps you, you can go ahead and redraw it as a net, but if you do, just make sure that you're putting all your numbers exactly in the spots that they need to go. But this picture is pretty straightforward. Just pay attention to what your height is. The height of the triangle is this one right here, is the 5.2. And then you've got your rectangle, so pay attention to which numbers go with the rectangle, and those are going to be the 7 and the 6 go with the rectangle for your formula or area for those. So go ahead and pause your video, and when you come back, you're going to see how we would go about solving this question. So we're going to start with a triangle. So we know the formula for area of a triangle is area equals 1/2 base times height. And we already mentioned that the height is 5.2. The base is going to be 6 centimeters. So you've got to look at the front triangle at this guy right over here. You're going to look at, let me do it again, this guy right over here, and that's going to show us that it's 6 centimeters. So we're going to plug in our information. Off to the side, I went ahead and multiplied 5.2 times 3, and I got 15.6. Now, if you notice what I did here is I went ahead and drew 2 small triangles at the bottom of my page, and inside of them I wrote 15.6 because I found the area of the first triangle, and it's going to be exactly the same as the area of the other triangle as well. So next, we're going to go ahead and talk about the rectangle. So the area of a rectangle is area equals base times height. So I'm going to go ahead and plug in my numbers. The base is 7, the height is 6, and I get 42 squared centimeters. So over here you can see that since I have 3 rectangles, I'm going to go ahead and draw 3 of them in there, and I wrote 42 in each of those boxes. Now if you look at the picture, there's my second rectangle that's down at the bottom, and then the third one is the one that's on the right side of that triangular prism. So this prism kind of looks like a tent to me. So of course what we have to do next is make sure that we add all our areas together. So you can see here that I went ahead, I added my first 2 triangles together. Now I'm going to go ahead and add my rectangles together, all in there, and giving me a final answer of 157 2/10 centimeters squared. So it took a little bit of work, but it really wasn't too bad because the numbers weren't that bad for this example. So let's go ahead and look at the next page. Here we're going to use something that they called orthogonal drawing. So we're going to also find surface areas of any triangular prism by adding the areas of all the sides of a prism using an orthogonal drawing. So what that means is sort of like what, and I kind of like this, is they take your triangular prism, the 3-dimensional picture that you have, and they're going to break it up into and draw each shape. So here, if you're going to notice, here's our first shape back here. So this is our first triangle, and it's the same one as this guy right here. So you would find the area of that triangle first. So of course we're going to start with writing our formula and plugging in our numbers. So looking at this, we know that the area of that triangle is going to be area equals 1/2 times 15, which is our base, times 8, which is the height of it. And I got that information from the frontmost triangle, and I get a total of 60 meters squared. So once I found that 60, I'm going to go ahead and write it inside that triangle. Well, notice I also wrote it inside the second triangle as well, because they are exactly the same size and shape. So next I'm going to go to my rectangle. So we're going to look at the bottommost rectangle. So look at the dimensions of that bottommost rectangle. We have a base that's 15 and a height that is 20. Or you could think of it as length times width, of course. So 15 times 20 is going to give us 300 meters squared. And notice that I wrote the 300 in the middle of my box over in my orthogonal pictures. So now we're going to talk about the top box, the right top side of it. So of course we're going to go ahead and list the formula there, as well as putting in their dimensions. 17 times 20 is going to give us 340 meters squared. So I'm going to write that number inside that middle box. And our last one's going to be that back part of the rectangle. And we're going to go ahead and start with the formula again. 8 times 20 gives us 160 meters squared. So what I would do here is I would add up all the numbers that I have here. So I would take my two triangles, and I would add my 60 plus my 60 plus 300 plus 340 plus my 160, and that's how I'm going to end up getting a total surface area of 900 square meters. So now you guys are going to give this a try on your got it part. So start with example B. Now I could tell you this, I know there's not going to be enough room on your in your book. So this is where you're going to get that sheet of notebook paper out. So you're going to be go ahead and at the top of that sheet of notebook paper, go ahead and label it B. And then when you're done with example B, you can go ahead and label it example C and get started there. Now remember, before you get started, you need to find the area of the triangles. Now there are 2 of them. So when you do, I would like for you to go ahead and draw a picture of the triangle. And as soon as you find that area of the triangle, put the number inside of it. So 2 triangles, they will be the same size and shape. Now there's a little tricky part about example B. So I'm going to show you this right now. Now look at the triangle in example B. You'll notice that we have our triangle that's right here. So I'm outlining it in red. Pay attention to what the base is. That's pretty easy. So it's going to be this guy right here, the 4 meters. But what is its height? Its height, you guys, is 5 7/10 meters. This 7 right here, we're not using. That's the slanted height. That's not how tall that triangle is. Okay, so we want the actual straight height from the topmost part going straight down. So those are the 2 numbers that you definitely want to make sure you're using for your triangle. And the other thing I want you to make sure you remember is you need to also then find the area of the rectangles. There are 3 of those guys. Right, so be sure that you're looking at each individual picture and making sure that you are using the correct dimensions for the rectangle. Now I'm going to tell you this. On the rectangle, you're going to be using those other numbers that we haven't used yet. Okay, so and also each of those rectangles are different sizes. So you're going to have to do it 3 times. This example is different than example A. Because in example A, the rectangles were all the same size and shape. But on this one and example C, they are different. So pay attention to the numbers and be sure to draw them out and put in the numbers like we did with our previous example. All right, go ahead and pause the video and give this problem a try. And when you come back, you'll see how you did. So here I went ahead and just did example B all on its own. So I'm going to start with the triangles. And so I'm going to start with writing the formula for area of the triangles and then filling in its dimensions. So we've got area equals 1/2 times 4 times 5.7. So that is what my triangles are going to be. So I went ahead and took half of 4. I got 2. 2 times 5 7/10 is 11.4 meters squared. So then I'm going to go ahead and draw my 2 triangles because remember you've got 2 of them. Now this is the part with the orthogonal pictures of the drawings. You need to draw a picture of the triangles. So I drew my 2 triangles because remember it's a triangular prism, so the top and the bottom, because those are the real bases, are the same size and shape. So I'm going to go ahead and do my triangles, and inside of them I'm going to go ahead and write 11.4 since that's what I just figured out the area of those triangles were. Next, I'm going to go to my rectangle. So I start with my area of my rectangle. Now the rectangle that I chose to do first is the one that's kind of facing me the closest. Those dimensions are 8 6/10 meters for the base, and the height is 5 7/10. And you can see that I have it outlined in my picture there. So when I multiply my work, and you can see that I did that off to the side, I ended up getting 42 200 meters squared. So look over to where I had my triangles drawn. I went ahead and drew a rectangle, and I got 49 200 meters in, or square meters that I wrote in there. Now I'm going to go on to my next rectangle. Now I'm talking about the one that's on the bottom. So notice what I plugged in, 8 6/10 times 4, and I got a total of 34 4/10 meters squared. So I drew my second rectangle, and I went ahead and wrote in there 34 4/10 meters squared. And now I have to do my final triangle. So you can see that I went ahead and labeled it. I'm sorry, I said triangle. Rectangle. You can see that I labeled it rectangle, plugged in my 8 6/10 times 7, multiplied that guy out. I got 60 2/10 meters. Oops, I forgot my little itty bitty cute 2 there. So let me put that in there now. So next I need to add up all my numbers. So I went ahead and went to a different screen because I ran out of room, and I just kind of shrunk all the writing that I had done already. So now what I'm going to do is go ahead and I'm going to add up my two triangles so that you were each found to be 11 4/10. So 11.4 plus 11.4 gives me 22.8. I'm going to go ahead and add my first rectangle in there. Now notice what I did, and I kind of did it in orange so you can see. I had to line up my decimals. So to fill in the gaps, I went ahead and just put a 0 there so it didn't look lopsided. And I kind of did this throughout my problem. So I did it again here for the second rectangle, got my number, and I went ahead, I'm going to go ahead and add my third rectangle and get my final answer here. So once I added everything up, I found that the total surface area of this shape happened to be 166.42 squared meters. And that was a lot of work, but you can see like how if you organize your work so it's nice and neat, you can see how easy it is to know what you're adding at the end. But there's a lot of places to make errors, which is why you need to take your time, and you also need to make sure that you're writing neatly so you don't mess things up. So let's go ahead and look at our next example. So of course we're going to start with our triangle. So you can see here I've got my formula written, and I found that each triangle was 5 feet squared. So I drew my two triangles with a 5 in the middle of it, because remember, a triangular prism has a base that's a triangle, and the two bases will be exactly the same size as well. So then I'm going to move on to my rectangles. So the first rectangle is the top one, and you can see how I plugged in my numbers and my dimensions and my multiplication, and I drew my rectangle and wrote 21.6 in the middle of that one. I'm going to go ahead and get on to my second rectangle. Now this one right here is the bottom part. So I did 5 times 4, I got 20. And you can see how I drew that second rectangle and wrote the 20 in there. And then my final rectangle, which is that side one, which is in the back, I went ahead and figured out that guy's area, and it ended up being 8 feet squared. Well, remember, when you're all done, you have to add up all the numbers. So you can see here that I'm adding all my numbers together, and I'm going to end up getting a total surface area of this triangular prism to be 59 6/10 squared feet. So let's go ahead and look at our last example. Now I'm going to be honest with you, I really do not like how they drew the net of this, but I'm going to try to explain it to you guys so it sort of makes sense to you guys. So what they have here is they've got a bakery, boxes, pastries, in a triangular prism box as shown. We want to find the amount of cardboard that's used to make the pastry box. All right, so on this one here, we're going to start with the triangle part first. So looking at the top of our top picture, so you can see here that I went ahead and outlined it in a pretty dark purple, I guess, is the color. And so if I write my formula for area of a triangle, it's going to be area equals 1/2 base times height. So go ahead and write that down in that same area that I am, because they really don't give you a lot of room in the work zone here. And if you want, actually, you could do this on your separate sheet of notebook paper. So I'm going to have my 1/2. Now, the base of that triangle is 7. Because think about, where's the flat part? Like if the triangle were going to be standing upright, this would be its base right there. And the height is that dotted red line, which is 12. So I'm going to work this out. So I'm going to do 1/2 of 12, which is 6, and do 7 times 6. I get 42. So now, remember, there's two triangles here. There's the one that I have outlined, and then there's that bottom one, which I'm going to go ahead and outline in a different color for you. Let's see if I can get it straight. Here's this one, and this one. Okay, so that's the top and the bottom triangle. So really remember, we have one triangle that's 42 and the other triangle that's 42. And you guys know me, I'm really big into pictures too. So I'm going to go ahead and draw my two triangles here and put the number 42 in each of them. But let me find a darker color that is going to show up better. Okay, and so let me start that over. Sorry guys. All right, so that's a little bit better there. So, of course, this is in inches squared. All right, so now what I'm going to do is I'm going to go ahead and take away my drawings here, and we're going to talk about the little sides. So now looking back at our picture, and I'm going to go ahead and choose a different color here. Let's do dark blue. I'm going to be talking to you about, that's going to be too similar. So let me change that color. Let's go back to purple. So we're going to go ahead and talk about this line that's right over here, this box, like that. I do a very good job at outlining my box, but we're going to talk about that one there. So since it's in the shape of a rectangle, we're going to go ahead and write our formula, A equals base times height. So you can see here that the base is 12 and 5/10 inches long, and the height is 1 inch long. Well, 12.5 times 1 gives us 12.5 inches squared. Now the shape that I have outlined is the front side. Well, keep in mind it's got another side that's exactly the same length, and it's this guy way back here. So this is the exact same size and shape as the one that we just figured the area for. So we have two rectangles that are that size. So we're going to go ahead and just draw our two little basic rectangles up here. Oops, let me get that right. All right, so I know it's really teeny tiny, but inside each of those I wrote 12.5 and 12.5. Now I've got one more, and that's this back guy right over here. So you're going to see it right. Let me go a little bit thicker, and let me use that one there. So now we're talking about this back guy all the way over in this area. So he's like the back of it. I kind of think of this as a pizza box. Well, look at those dimensions. So when I'm writing this information down, I've got area equals my base times height. My base is going to be 7 inches. My height is 1, which means that my area is 7 inches squared. So for that little rectangle guy, I've got 7 inches total for that little itty bitty piece there. So I can draw a small rectangle here and write the number 7 inside of it. So now what you're going to end up doing is you're going to end up adding all these numbers together. The 42 plus the 42 plus the 12.5 plus the 12.5 plus the 7, and that is what's going to give us our final answer of 116 square inches of for this cardboard pizza style box that they're using for pastries. All right. So let's go ahead to our next one. What I want you guys to do is you're going to work on questions 1 and 2 only. Now you need to complete these on notebook paper. So I don't mind which strategy you use, whether you're going to go ahead and just, find each area like of the triangle and then the rectangle, which means you still have to label them. Triangle, triangle, rectangle, rectangle, rectangle. Or if you want to go ahead and use the picture of the octagonal, not the octagonal, the orthogonal pictures. So over here in this example, it is telling you for number 1 that they want you to use the way we did in examples 1 and 2. And then for number 2, they want you to use example 3. I'm going to be honest with you. I really like the idea of drawing the pictures individually, the boxes, and then putting the numbers inside of them. But I will leave that strategy entirely up to you. However, you do have to show me every formula. And remember, there's 2 triangles and 3 rectangles for each of these examples. All right, you guys, I will see you back in class, and I hope that you have a good evening.